Hello Science 30s. Today we are introducing Unit A, and so we're coming full circle back in our textbooks to the very start with biology. And so the original thought was we have biology at the end because there's going to be a lot of terms and just the flow of how all these terms work together in our body systems. And we're hoping at the very start that we'll remember these terms freshest for the diplomas because there is so much terminology. We didn't want to forget it if we started with biology. So please make sure as we're studying through this, taking special care at knowing all these terms, and there's going to be a lot of terms and definitions, but then understanding how they all work and they're tied together. The first part of our notes is starting with the circulatory system, and we're going to be looking at how this functions and how it works to keep us alive, and then everything that's related with it, which is pretty much everything. This is how we interact with the external environment, because when you think of it, how do we get oxygen? How do we get sugar to our blood and to our muscles to do things? How do we take it in from the external environment, so air and food, and then how do we get it into our bodies? Also, when we have a virus or a cold, like right now, how do we defend against these pathogens? The answer is our circulatory system, and we're going to look at all of this. There is trillions of cells that are all closely packed together. And all these cells work together and they have specialized functions. Not every cell is the same. There's going to be things that we're talking about like red and white blood cells, two very different things. And we can compare it to like the inner workings of a whole city. Each different business has a different function. Each different cell has a different function. And so each cell requires an ongoing supply of all these nutrients. They need water, they need minerals. All of this needs to work together. So how else does the circulatory system work? Well, it was removing waste, and it's a transportation system of all these different things. Whether it's, like I'm coming back to it again, oxygen, sugar, water, nutrients, minerals, they have to reach every part of our body and they'll get used there. The main unifying factor is the blood and how it has to be carried to each system. And then with that, we're going to take a look at the heart, the blood vessels that all make up the circulatory system. So here we go. Here are the major functions that we're going to focus on for the circulatory system. One is transportation. Two is how we exchange gases and different waste products. How we transport chemical messengers and things like hormones, how we distribute body heat, and then how do we defend against diseases. So ideas about the heart have been thought about for a long time, and many famous physicians, many famous great thinkers have thought about it, but it's hard to study the heart because you feel it, you can see that you have a pulse, you know something's beating inside your heart. However, how do you observe it? How do you see an actual heart working without, okay, carefully cutting it open, but then it stops, and people know when you take it out of the body will soon die right away. Medical technology versus the thoughts were very far apart at these points. And so the first way was understanding heart dissections from animals, and they started to piece it together that, oh, the similar structure kind of was present, just smaller or bigger in all these different animals. Other famous thinkers like Leonardo da Vinci, right? He was credited with understanding and figuring out a lot of the ideas of the circulatory system, just how does the heart actually move it, or how does it actually work? It's tough because you can't see it when you don't have the technology to help support it. And then here's another one, was William Harvey, and he questioned the early belief and developed the currently accepted knowledge that it's the heart's ability to pump blood throughout the entire body. And this is where we got cardiac output, and we're going to talk about stroke volume, and we're going to talk about things like a resting heart rate. And so they kept building and building on top of each other. And you can see each of these scientists was highlighted in the textbook. So if you wanted to go back to it, you can see how they're highlighted and some of their works that they've put forth towards understanding the heart and how it moves things around. So here are the main kind of topics we're going to talk about in our circulatory system. This first video I'm going to put out is only going to cover blood vessels and the heart. And I'll put out another one where we're going to start talking about blood, blood pressure, and immunity. So jumping into the parts and starting to go with a lot of these terms, we have vessels. There's three types of blood vessels that we're going to learn about: arteries, veins, and then capillaries. When we look at arteries, simply put, arteries always carry blood away from the heart. And so when we talk about arteries and veins, it's always the direction of flow from the heart or to the heart. Arteries are always away from the heart. After that, there's some descriptors and just some common themes about them, like they're very thick, they're muscular, and they have elastic walls. They carry blood that's under high pressure because it's coming away from the heart, so it's on that kind of contraction of the heart that it's squeezing everything through, so it's coming through that artery at a high pressure. And then we have smaller arteries are called arterioles. And another key point, the largest artery is the aorta. So this is the one coming right off of the top of the heart. And we're going to look at a picture of the heart and we're going to see it. And so when we start looking through them, please make sure when we talk about some of these conditions, make sure we're kind of getting them in our heads as well. Okay, so what causes high blood pressure, like this hypertension? Make sure we're kind of making notes and having these highlighted of, oh, okay, this is this, and it's like, oh, we understand what the ailment is. So I already mentioned veins, and these are the ones that carry blood towards the heart. And they have thinner walls than the arteries because they're not under that high pressure, because there's nothing to actually squeeze and push it back. That's why they have these valves, and they prevent a backflow of blood. So that's why you can't just pool blood in your feet, because the blood comes down from your heart, it pushes it, but then it's pushing the blood back up. But the reason it just doesn't stop and fall all to your feet and just swell your feet is there's these valves that prevent it from just kind of flowing downhill or getting pulled down because of gravity. And then we have small veins are called venules. These varicose veins, so when you start to see varicose veins like those blue spider lines, or spider veins they sometimes call them, they're caused by damaged valves. And just like how the largest artery is the aorta, the largest vein is called the vena cava, and again, right near the heart. Our last blood vessel that we talked about out of the three was capillaries. And this is the interesting transition between where arteries and veins, and this is the separation between them. The main characteristic of the capillaries is it's going to have all this blood flowing through it, but this is where the exchange of materials is going to happen. So whether it's gas exchange in the lungs and in other body tissues, or where we're actually letting things kind of diffuse through this one cell layer thick walls that these capillaries have, this is where we allow the dropping of materials or the absorption of these waste materials in our body so it can then be carried out through our whole body. And so what we see whenever we kind of get a bruise is when we actually rupture these one cell layer thick capillaries and we start to see kind of blood. It's not that we're bleeding and bleeding and bleeding, but we have this little bit of a rupture, and our body will then heal and kind of repair itself with these bruises. So for the next part, we're going to talk about the heart. And with our heart, we have this other term we call cardiac. And when we talk about cardiac output or a cardiac event, they're talking about the heart. So it's the medical term, if you will. We're just simply going to call it the heart for the most part. We're going to talk about the anatomy, and we're going to talk about the heartbeat part. So the anatomy of the heart is it's a giant muscle. It is a special type of muscle. So when you think of muscles, like in our arms, and when we just have these movement muscles, they're a certain type of rough muscle. When we talk about our lungs, they're another type of muscle, but they're a smooth type of muscle. The cardiac muscle or the heart muscle is its own type of muscle. The only time it's found is in the heart, and it's a type of muscle that never gets tired. You think when you do a bunch of working out or running, your muscles will start to fatigue. Well, your heart muscle will never get tired, so it's a very important part, or a very special type of muscle at that. And it's going to pump this blood your entire life and never stopping to your whole body. We're going to learn how it's divided by the septum, and it's going to have a left and a right side. And for the most part, this right side pumps deoxygenated blood to the lungs and then back to the heart. And so we're going to call this the pulmonary circulation. Pulmonary is, well, layman's term, or in real simple terms, we're going to talk about the lungs and the oxygen circulation. So the other side of the anatomy is the left side, and this is the part that's carrying the oxygenated blood, because when we start looking at it as a whole, we have the pulmonary circulation to carry the blood to the lungs. It has where it can pick up the oxygen, then it comes back to the heart, and then it goes out to the body. And this is the systemic circulation. So it's delivering it to the rest of the other body systems. This coronary circulation, this is the big one, right? This is providing the heart with oxygen and nutrients. And so there's also a part where there's blood delivered to the heart because it is a muscle. It needs oxygen, it needs sugars all the time too. So this is kind of a third one. If these ones are blocked and if there's something wrong with the coronary circulation, the result is a heart attack. Here is an outline of a heart. And typically, if you're ever writing a test, you will see a picture very, very similar to this one. This is like if you were staring at a person's body and looking at them, and they will have the left and the right, and it's kind of like how you have to place yourself in the body. Now, this is tough because we would have done a heart dissection in class, but you have to make sure that when we're going through it, we're studying the parts. And I'm going to post another video or two to help with a virtual dissection. And a lot of them, unfortunately, are paid, so please do not pay for them. But we'll be able to sort of piece through and do a virtual tour of what the insides and the parts of the heart look like. But you should make sure that you practice and understand all these different parts of the heart. And we're going to go talk a little bit more about them, but you have to make sure you're learning these parts of the heart. I'm also going to post another video about these two different circuits. And we have to understand, even though I'm showing them as two separate circuits, and we're going to start to understand them as a circuit of how they all flow, you have to remember they flow one into each other. And so one of the videos I'm going to post is it's not that you have a pulmonary circuit and then you have a systemic circuit and they're two little isolated circles. They are not. You can think of it as how if you made a figure eight and you start at the top, you flow through the middle, and then you cycle through the bottom of the eight, back through the middle, cycle back up top, and it's making this figure eight shape. That's what you should think of as this whole circulation. So I'm going to go through the anatomy a little bit quicker because you don't need me just to read it through. This will require you looking through different videos, or if you can find a good virtual dissection and trying to know where the atriums are, where the ventricles are, and knowing that these atriums are these upper chambers, the ventricles are the lower chambers. And then there is a left atrium, right atrium, a left ventricle, a right ventricle. And we're going to start going through these different parts of the heart. So with this anatomy, make sure to take a pause right for today. I would have had this stop in my notes. I'm just going to go a little bit more into the heartbeat, but make sure when we're doing this, review these systems and review the parts. And so take a stop for today once you've kind of gone through it. You're going to actually come through it and practice through it as well. Now that we've gone through the anatomy of the heart, we're going to talk about the heartbeat, or kind of what you see here is the lub-dub. And so this is called the lub-dub because that's kind of what your heartbeat actually sounds like. And you can hear two parts to one heartbeat. And so there's four main parts to the heartbeat. One, heart muscles relax, chambers fill with blood, the atria, so the atriums, they contract, and the valves, so the atrial lunar valves, they open and you hear this dub sound. The ventricles contract and the semilunar valves open and you hear the lub, and this is heard first. And so you hear lub dub, lub dub, and then the blood is pumped out of the heart through to the body. So the blood flow is atrium to ventricle, but the contraction is reversed. Here you can see how it kind of flows and a quick little graphic of how the blood actually flows through the heart. When we talk about the heartbeat, these are due to the electrical signals that they are getting, and they help coordinate the contractions of these heart chambers. And so the diastole occurs when the ventricles of the heart are relaxed, so they fill up. The systole occurs when the ventricles of the heart are contracted, so that's when they're squeezing and they're pushing to empty. This is an important part of the heart flow because it is the measurement that we're taking of how much blood is then flowing through. And we get this pressure or this pressurized blood during these contraction phases or just during these rest phases. And so we have a measurement of systolic pressure over diastolic pressure. Essentially, it's during the diastole, the ventricles are relaxed, the blood pressure is low. During systole, or systolic pressure, this is when they're contracted and it's at its highest. Blood pressure is measured using a sphygmomanometer, and when you see a number, you'll see two numbers, and so it is systolic over the diastolic. And so you have the high pressure over the down low pressure. If you've ever gone to a pharmacy or sometimes at the supermarkets near the pharmacy at the back, they will have the blood pressure machines where you actually stick your arm in, press the start button, and you can actually measure your heart pressure and you can measure your blood pressure free and you can see what the measurement is and they'll kind of explain it with this units and you'll see the units are mmHg. With the heartbeat, there's also heart conditions that pop up that I wanted to just kind of touch points on. If you've ever heard of a pacemaker or this artificial pacemaker, well, that's when the heartbeats are too slow or they're too fast or they're erratic. And so essentially you need something to set the pace of your heart. That's why it's called the pacemaker, is because it's providing this consistent pacing and it's a timing device essentially for the heart to keep a rhythm. And so most times it will just let the heart run its course, but sometimes people's heart pressure will drop for a reason, or it might just speed up for a reason. The pacemaker will help keep a regular pace on it. Or tachycardia, this is when the heart rate exceeds 100 beats per minute. As a result of exercise, this will happen. It can happen because of drugs such as caffeine or nicotine, but the issue is when it gets too high. And a lot of these are measured with this cardiac output. I talked about that right at the start. And we're talking about, okay, when the heart is working too hard and the cardiac output. And so we're going to figure that out next slide, where it is stroke volume, or this SV, times by beats per minute. So going with these measurements, we have cardiac output. And so the stroke volume is the volume of blood in one beat. This CO, this cardiac output, is the volume of blood pumped in 1 minute. And then we have our heart rate. And so hopefully if we're able to figure out our heart rate, you can put those two fingers to the side of your neck and you've probably found your heart rate before, or we have machines that will measure it now. But essentially it's taking how many beats per minute, your heart rate, timesing it by your stroke volume of 1 beat, and then you get your cardiac output. So I've talked about all the heart anatomy and the heart volumes and moving things with a heartbeat and everything. Before I go on to blood, that will be my next video. So please make sure we're reviewing a lot of these first terms, and then I'll be posting a video about blood and blood typing shortly. Have a great day. Make sure to study lots of terms. Come back frequently. Take care.